question number 66, which says that which of the following is our incorrect regarding graph of log K equilibrium versus 1 by T. So first of all, we have to find an expression which relates the value of log K equilibrium and the temperature. So you must be knowing that the value of delta G naught at equilibrium is minus 2.303 RT log K equilibrium, and delta G naught we can also write delta H naught minus T delta S naught is equal to minus 2.303 RT log K equilibrium. So now you have to establish a relation between log K equilibrium and 1 by T. So rearrange this equation. So it will be log K equilibrium is equal to minus delta H naught divided by 2.303 RT plus delta S naught divided by 2.303 R. I hope this is clear to you. Ab log K equilibrium is on the y-axis and 1 by T is on the x-axis. तो ये क्या हो गया हमारा slope, because it follows the straight line equation, that is y is equal to mx plus c, and delta S naught by 2.303 R will be the intercept. So now you have been given the value of slope, that is delta H naught by 2.303 R, but it should be minus of that one. So this is the incorrect option. Now you have the second option which says that the intercept. So we have found out that the intercept is delta S naught by 2.303 R. So this is the correct option. And in the third case, you have been given that reaction is endothermic. So what do you mean by when a reaction is endothermic? It means the delta H naught value is positive. So अगर delta H naught value positive है तो slope की value क्या होगी? Negative. अगर यहाँ पे delta H naught negative होता means reaction will be exothermic. So the value of slope will be positive. So this option is absolutely correct. So the only incorrect option, that is option number 1. So now we have question number 67, which says that methane and sulfur dioxide are taken in mass ratio of 4:1 at 2 atm pressure. The molar ratio of methane and sulfur dioxide effusing out initially is. So this question is related to the Graham's law of effusion. So the rate of effusion is directly proportional to the number of moles of gas and inversely proportional to the square root of molar mass. So we can write it like this: rate of effusion for CH4 divided by rate of effusion for sulfur dioxide is equal to number of moles of CH4 divided by number of moles of SO2 multiplied by under root of molar mass of SO2 divided by molar mass of CH4. So the number of moles of CH4 is equal to weight divided by molar mass, and you have been given that they are in the mass ratio of 4:1. So we can write it like this: 4x divided by 16, and number of moles of SO2 will be x divided by 64. And molar mass of SO2 is 64 and molar mass of CH4 is 16. And the rate for CH4 we can also write it like this: number of moles of CH4 diffusing out by per unit time, and here you have to calculate a particular time. So it is equal to number of moles of CH4 diffusing out divided by number of moles of SO2 diffusing out. So it is equal to 32 by 1. So the ratio will be equal to 32:1. So option number 1 is the correct answer. So moving on to the next one now, you have question number 68, which says that which of the following is our correct statements. So the first statement is, so spontaneous reactions always occur very rapidly. So this is not always true, because suppose take an example for the corrosion. You know that corrosion is a spontaneous process, but it is a very slow process. So we cannot say that spontaneous reactions always occur very rapidly. So this is the incorrect statement. And the second statement says that for spontaneous process, delta S system may be negative. So for spontaneous process, the criteria is the delta S for universe is greater than 0. And you know that delta S universe is equal to delta S system plus delta S surroundings. So for the spontaneous process, sometimes delta S system can be negative, but delta S universe will always be greater than 0. So this option is absolutely correct. Now you have the third statement, which says that in an irreversible process, system remains at equilibrium throughout, which is an incorrect statement, because in the reversible process the system and surroundings are present at equilibrium, but in the irreversible process, as the process is very fast, बहुत जल्दी process होता है, so the system cannot remain at equilibrium with the surroundings. So this option is the incorrect option. So the only correct option, that is option number 2. So moving on to the next one now, you have question number 69, so which says that which of the following salt will give lowest pH in water. So the salt which comprises of a strong acid will give lowest pH in water. So the acid जितना ज़्यादा strong होगा, the pH will be very low. So अगर हम first option में देखें, it is NaCl, and you know that it is comprising of NaOH and HCl, so it is neutral. So pH will be equal to 7. Now you have the second case, that is copper sulfate. So it is a salt of copper hydroxide and H2SO4, and you know that H2SO4 is a very strong acid, so the pH will be less than 7. Now you have the third case, which is Na2CO3, so which is comprising of a strong base, that is NaOH, and a weak acid, that is H2CO3. So the pH will be greater than 7. Now you have the fourth option, that is CH3COONH4. So it is comprising of the acetic acid, that is a weak acid CH3COH, and a weak base, that is NH4OH. So the pH will be high. So the option number 2 will be the correct answer, which will give the lowest pH in water. So option number 2 will be the correct answer. So let's move on to the next one now. You have question number 70, which says that assuming air as an ideal gas, what will be its effective molecular weight if 500 cc sample of air at 27 degrees Celsius weighs 0.6 gram at 1 atmospheric pressure? So first of all, write the ideal gas equation, that is PV is equal to nRT, and number of moles we can write it like this: weight divided by molar mass. And now you have to calculate the effective molecular weight. So it will be equal to weight into RT divided by PV. And now you have been given that weight is equal to 0.6 grams. 0.6 into value of R, which is equal to 0.0821 liter atmosphere per mole per Kelvin, into temperature. So temperature is 27 degrees Celsius. So it is equal to 300 Kelvin. So divided by pressure. So pressure is 1 atmosphere into volume. So volume is 500 centimeter cube. So convert this into liter. So it will be equal to 500 divided by 1000. So if you calculate this, your answer will come out to be 29.6 gram per mole. So option number 4 will be the correct answer. So moving on to the next one now.